Congratulations, Year 12s, you are officially done with math methods, which is super exciting. Today I have for you my suggested solutions. Big disclaimer, this is not saying that this is 100% correct. I hope it is, but it's really easy to make a mistake, particularly with multiple choice. So feel free to let me know nicely in the comments if there are any errors, but hopefully it should be all good and you can compare your answers to mine. So let's get started. We've got the methods exam 2 and we'll get started with question 1. We've got a function that has a range between 6 and 12. That function could be, we can see that they're all cos functions, so usually cos has a maximum minimum of -1. I can then see that I want it to have a range between 6 and 12 and the options of dilations are either a 3 or a 6. So if I dilate by 3, so then we have an amplitude of 3 and -3, and then I could add 6 to it. Or 9. So if I add 6, I can see that the maximum will be 9, which is not what I want. But if I added 9, then the maximum would be 12. And if I added 9 here, then the maximum would be 6, which is awesome. That's exactly what I want. So it was just a bit of trial and error that I chose those numbers, but it looks like I'm going to be multiplying by 3, adding 9. Obviously, you can try multiplying by 6 as well. Either way will work. So times by 3, add 9. That's going to then be C. Doesn't matter that there's a negative, it just means there's a reflection there. Question 2 says, what's the asymptotes of this graph? So we're looking for a general solution. So usually asymptotes for a tan graph, if you think about them, they're usually at pi on 2. And then what we do is we add 1 pi to get to the next cycle. So that would be n pi. Now in this case, we can just have a look at the transformations that have directly affected the x. The first thing that I can see is that there's a dilation by a factor of 1 on pi from the y-axis. So what that means is that we're dividing everything through by pi. And you can also think of it, this is the way that you find your period. You would divide by pi. So that is going to end up being just a half plus n. And then we can see that this means that we've moved the whole graph left by a half. So we'll subtract a half and that will equal to n. They've used k, I've used n, same thing, but the idea is that the asymptotes will equal at x equals n, x equals k. So I got A for that one. For question 3, we've got a particular graph. Which of the following best represents the graph of y equals f of x plus 2, negative x plus 2? So that negative x means that there's a reflection in the y-axis. So all of my values are going to switch over in terms of across the y-axis there. So all my x values are swapping over. So for example, I can see I have this endpoint here. That's now going to flip so that I have an endpoint over here. The endpoint previously on this side will appear on this side. My x-intercepts, they're actually all going to pretty much be the same because it's at -3, -1. So that will flip over to 1, -3, but it's just going to flip. Even this is going to remain the same. The difference is going to be in that minimum point. So the minimum point is going to flip over. So like that. So I've gone ahead and mapped it out. All right, so that's that's this part here. And then I just need to increase the whole graph by 2. So I'm just going to grab the graph and I'll move it up by 2. So for reference, it was at 1, now it's going to be at 3. So that's what your graph is going to look like. And that is going to look most closely like B out of all of the options. So that's for question 3. Question 4, it says consider the simultaneous equations, find the value of k for which there are no real solutions. So this is just a stock standard question. You need to get it into the y equals mx plus c form. For no real solutions, you want the m to be the same, so the same gradient, but you do not want the y-intercept to be the same. So we're going to rearrange it. You can use your CAS calculator if you need to help rearrange it. I'm just going to try and do it all in one step so it's nice and quick. So I'm going to take the kx over, and there's already a k squared, and then I'm going to divide both sides by 3. So that's for equation 1. And then for equation 2, so I'll take the 2x over. The constant in this case, I'm just going to put it in a bracket so I know that that's the constant, and then I'm dividing everything through by the factor in front of y. So 2k plus 1, 6 minus 2k there. All right, so as we said, we want the gradients to not be the same. So let's find for which values that they are the same. So I'm just going to make them equal to each other. Or we could say like we don't want them to be the same. Now I would just use the CAS calculator for this. You can do it in your head as well, of course, but I just want to release my mental load and do as little as I can in my head. Solve that equals to -2 on 2k plus 1. Solve for k. We get k is -2 or k is 3 on 2. Okay, so those are our two options. One of them is going to give me no real solutions, which means it's parallel. One of them is going to give me infinite many solutions. So you just want to check which one that is. And the way that we do that is by looking at our C value. So for no real solutions, we want them to be different to each other. I just realized that the denominator here, I just copied the top. It didn't really affect the question so far, but if you had any questions as to why it was that, there you go. That was a silly mistake, but like I caught it before we used it. All right, so let's start off with a is equal to -2. So if that's the case, for equation 1, we'll have -2 squared, which is 4 on 3. For equation 2, we're going to sub that in. So -2 times -2 is +4, and then that'll be 6 and 4 will be 10. And if I sub it into the bottom, 2 times -2 is -4 plus 1 is -3. So obviously these are not the same. If you're in a bit of a rush, I would just go ahead straight away and select A. But if you want to make certain that that's the case, you can go ahead and sub in 3 on 2 as well. So that'll be 6 minus 2 times 3 on 2 will be 3. So 6 minus 3 is just 3. And then if I sub that into the bottom, that'll be 3 plus 1, which is 3/4. I don't know why I did that for equation 2. That was a bit silly. Anyway, equation 1, if we put in 3 on 2, so 3 on 2 squared is going to be 9 on 4. 9 on 4, and then divided by 3, which is the same as multiplying by 1/3. You'll see that you also get 3/4. So that's the same. And it is not the same for part A. Okay, let's go through the next question. 5, which one of the following has an inverse function? So in order for something to have an inverse function, it has to be 1-to-1. And that means no x values and no y values can repeat each other. So if I go through and have a look at my options, so for part A, I can see that the x values repeat. Part B, nothing repeats, so far should be good, but I'm just going to check. Part C, these y values repeat, so it can't be that. And then part D, these y values repeat, so it can't be that. So it is B. Question 6, the trapezium rule is used. We've got two trapeziums to estimate the area bounded between the graph between 0 and 1. Which of the function will the trapezium rule be larger than the exact area? So before I go ahead and try to figure it out in terms of this, I'm just going to consider when is a trapezium larger. So it really depends on the type of graph. So if you have a graph like this, if I were to draw up a trapezium, you can see that this is going to result in a smaller area. Whereas if I have a graph like this will result in a larger area. And I mean, this will go the same whether it's the left-hand side or the right-hand side. So even if it's the right-hand side, it's still doing the same idea. Okay, larger. So what I'm looking for, because I want it to be larger, I'm looking for this situation here. Again, I mean, you can go ahead and think about what each of these graphs look like. We're trying to release the mental load, so I'm just going to graph them just so I can see what they all look like. So we'll go 3 minus e to the x. So we can see that that's got that particular shape there, like the first one. So that's going to be smaller. X cubed plus 1, that's going inwards, so that will be larger, so it should be B, but we'll just go ahead and check the rest like that. So that's larger, and this is larger. So you can see all of them have that particular shape. The two shapes are called convex and concave, but I just thought I'd leave that language out for now, but in case you're thinking of them. So what we're looking at is where it goes inwards, and that will be B. Okay. Question 7, consider the algorithm below. So when we get to an algorithm, I always think like, I don't necessarily want to execute the algorithm. I just want to understand what is it saying, translate it to English, and then do my own thing. However, with this particular question, it's quite short, so there is a chance that we can actually just execute it ourselves. And there doesn't look like there's any kind of function like, Newton's method or algorithmics or any of the other types of functions in particular. So let's see what we've got here. Question 7 says, consider the algorithm below. So we're going to assign 17 to n. We're assigning 5 to k. As long as n is greater than k, then the new n value will be n minus k, and then we print the n value. That seems pretty easy to actually just execute it ourselves. So I'm just going to go ahead and create a table. So n is what we're starting off with. We're assigning n as 17. We're assigning k as 5. As long as n is greater than k, then we're going to subtract them, and that will give me my new n. Okay, so n is greater than k. Yes, so let's execute it. 17 minus 5 will be 12. New n will be 12. K remains at 5. Again, it's greater than, so we'll execute it. Now it's 7. It's still greater than 5. 7 minus 5 is 2. However, 2 is smaller than 5, so it will not be executed for that last shot. So this one looks like the printed values I get is 12, 7, and 2. So that should be C. All right, question 8, we've got a random sample n Victorian households taken to estimate the proportion of all Victorian households that have vegetable gardens. We've got a 95% confidence interval. Just because it's really wordy, I'm going to start highlighting. In fact, you should be highlighting all the way through this exam. 95% confidence interval, we've got this particular sample here, and we're trying to find n. All right, so in order for us to find n, what I want to do is I want to equate this particular number, or either one, I just use the right hand side, to the confidence interval formula. So the formula is p hat plus z root p hat 1 minus p hat on n. Now I can see that we'll have two unknowns, which is p hat and n. So either you can do simultaneous equations with both of the sides, or I prefer to just find p hat first and just complete one equation. So the way you find p hat is that it's going to be the midpoint of your confidence interval. So we can add the two of them together. Divide that by 2. In an exam, I would not write that down. Let's just go straight on the calculator. Plus 0.552, divide that by 2. So p hat will be 0.4. And so I can see for the right-hand side over here, that'll be 0.552 is equal to 0.4 plus, for 95% confidence intervals, that is 1.95, I'm pretty sure, around there at least. 0.41 minus will be 0.6 on n. And so I will just go ahead and solve this. Again, I probably wouldn't write that all on the paper. I would just write this straight into my calculator. 0.4 times 0.6 on n. Oops, comma n. So we get n equals 39.5, which should be really close to 40. We round it up to 40 because we need to have that many samples in order to get that confidence interval. Okay, so that one should be C. Next, we've got question 9. Big question there. The idea is that we've got students walking to school or traveling in a different way, and whether they take longer than or shorter than 30 minutes. So because there are two stages to this, so they either walk to school or they don't, and they either take 30 minutes or they don't, I think of a tree diagram straight away because there's two stages to it. So I'm going to go ahead and start drawing up a tree diagram for this question. So they either walk or they didn't walk, and then they either took at least 30 minutes or less, at least 30 minutes or less. Okay, now in terms of the probability, so there's a whole bunch of things. I'm obviously not reading out the question properly or highlighting. You would spend a lot of time doing that, breaking it all down. So we've got m students and n students. So the total number of students that I have is m plus n. And so the probability of those walking is m on m plus n, and not walking is n on m plus n. Next it says, of the m students who walked, 20% took at least 30 minutes to get to school. So we're going down that branch of the walked, that's 20% took at least 30 minutes, that means 0.8. And then same thing for the other one, 40% took at least 30 minutes. So we've got 0.4, 0.6. All right, now what is it that we're trying to find? So given that a randomly selected student took at least 30 minutes, what's the probability that they walked to school? So we're looking for the probability that they walked to school given that they took at least 30 minutes. Now when we work that out, that's the intersection there, nice and easy because you just multiply across over the probability that they walked to school that they took 30 minutes regardless of whether they walked or didn't. Okay, so that top part there is going to be me just multiplying these two branches. So that'll be 0.2, and I'm just going to convert it straight to fractions also because I can see that in my answer. So 0.2 is 1/5, so that'll be m on 5m plus 1. That's 1/5 times the probability of w. Over, and now the probability that they took 30 minutes regardless of whether they walked or didn't. So that's those two branches added together. So that's m plus n, and then multiplied by 1/5 plus n plus n multiplied by 0.4, which is the same as 2/5. Okay, now this goes straight onto our CAS, and we're going to hope that it's going to give us the correct answer. So we'll go m on 5m plus n on first fraction, m on 5m plus n plus, and then second fraction, 2n 5m plus n. Whoops, I think I did that badly. I did. You have to be really careful in the exam. I need to get out of that fraction there and put a plus. There we go. Beautiful looking answer, m on m plus 2n. Let's hope that's one of the solutions, and I'm pretty sure it is, m on m plus 2n. There you go. That's that first one there. So I think the answer to this one should be A. Question 10. So we've got two particular functions, f of x, g of x. We've got an inequality needs to be greater than 0 is defined as. So basically we just need to figure out what is this fog graph and then where is it above the axis. So I'm going to use my CAS for that. So first thing I'm going to do is find out what g of x is. Sorry, my pen's gone a bit nuts. F of g of x is equal to, so I'm going to start writing f, and then every time I see x, I'm going to write g of x, which is sine x. So that'll be 2 sine x squared plus sine x minus 1. And I'm just saying, where is that function going to be above the x-axis? So we'll go into a calculator page. And we'll go ahead and write that out. 2 sine x squared plus sine x minus 1. Enter. So that's my graph there. Hopefully that's correct. Sine x squared plus sine x minus 1. Beautiful. That's my fog graph. And then saying when is it valid to. And it's in terms of sine. So on top of that, I'm also going to graph the graph of sine. And we're trying to see like what are the values of sine for which this is above the axis. Now I'm just going to zoom in so we can see this nice and proper. -1. That should be good enough. So what I'm looking for is this point to this point is when it's valid until. So I'm trying to find the x value, and that's when sine needs to be greater than that value. It won't be the x, but it will be the y value that will give us that x. That might not make a lot of sense. I'll explain it in a second. So let's first of all try to find these x-intercepts. So that's that one. Okay, so what we're basically saying is that it's going to be the same as the sine. The x values of sine needs to be between 0.524 and 2.62. But when we have a look at how it's written here, it's written in terms of what y value it's equal to. So I need to think about, well, what y values are going to result in these x values here. It doesn't really help because obviously, you know, these are all exact values, like a half or 0 or -1, whereas these are decimals. So that's not helpful. Now, if we think about, like, let's just start off with sine of 0. Sine of 0 happens at 0 and 2 pi. So if these x values were either 0 or 2 pi, then that would result in sine of 0. We can't see what values these are in terms of pi, but we can try to sort of estimate what they might be. We know the middle is going to be here. That's going to be pi, so that's definitely less than pi. Let's go ahead to our calculator page and let's just try out a couple of options. And at the back of my head, I'm also thinking we've got a half, 0, -1. There's not really that many options. If you think about sine inverse of a half, so what x value gives me a half, that's going to be pi on 6. So let's just try that number out. Pi on 6. And we can see that that is the same as this over here. So this value here is actually pi on 6. So here's my sine graph. Something like that. And what we're trying to say is from pi on 6, that is resulting in a positive fog graph. Now, the question is, well, what's that x value here, 2.62? Doesn't really matter, to be honest. And in fact, I tried out a few different values. It wasn't giving me anything in terms of exact values. What I can see is that it has to be greater than a half. Like the y value here needs to be greater than a half regardless. And the only possible answer for that is C. Now, obviously it's saying the y value needs to be less than 1, and that would make sense because that value there is 1. So what we're trying to say is that the y values needs to be between a half and 1, and during that time of sine, when it's between a half and 1, that's going to result in a positive of the fog graph. Okay, so I think that was a tricky question. I hope I explained it okay. That's just my thought process. I'm sure there's different ways or maybe a better way to explain it, but that's how I got to that answer. Question 11. So we've got the chart below shows the daily price of the stock market. Over which of the following time intervals did the daily price undergo the greatest average rate of change? So we want to see basically when the slope is the steepest. So 2 ways to do it. First of all, and the more accurate way really, is to go ahead and find the average rate of change for each of them. So you just do your y2 minus y1, x2 minus x1. I think that's going to take a little bit of time. So I'm going to just try to visually see where the slope is going to be the steepest. So let's start off with A, that's day 3 to day 10. So day 3 to day 10. So that's that. B, day 3 to day 17. So like I can see that the red is steeper than the green already. We'll grab a different color. Day 14, which is here, to day 21. All right, that looks like it's the steepest so far. And then one more color, day 14 to 28. Oh, that yellow is not very good. Let's try a different color. To day 28, so that's going to be 6, 7, 8 up here. I'm just going to draw a straight line to it. Don't know why it's not letting me fixate on it, but that's okay. So we can visually see that the line is going to be the steepest from days 14 to day 28. It's the steepest out of the 4 options. So the answer to this should be D. On to the next question. So question 12, there's a very specific way to do this question. It does pop up quite often. It's quite a lot for a multiple choice question, so let's try and do it as quickly as we can. So we've got for the normal random variable, we've got these particular probabilities. What's unusual is when they give you a interval. Usually they just give you greater than or less than one particular value. So just so we can understand what is going on, let's try and draw what's happening. So we can see that above 200, the probability is 0.325. And between 180 and 200, the probability is 0.589. Because we don't do this question when there's an interval. But when I've drawn it up like that, I can actually now find the probability of that particular section, which will be less than 180. So that'll be 1 minus 0.589 minus 0.325. Oops, that was really silly. Probably check that your calculator's working. Let's try that again. 1 minus 0.589 minus 0.325. So this probability here is this. Okay, so what do we know? We know that the probability when x is less than 180 is 0.086. And I also know that the probability that when x is, and I know when it's greater than 200, I already know that I'm going to use the inverse normal function, which means I need a less than probability, and that's why I'm going to write it in terms of less than 200. So that's going to be 1 minus 0.325, and that will be is equal to 0.675. All right, now we don't know the mean and standard deviation, so the way to do this question is to transform this into your z-score. That's minus the mean standard deviation. You can probably have done this straight away rather than writing out the previous one. Okay, I'm going to now find the inverse normal to give me what this particular value is, so what the z-score is. So we're going to do inverse normal, and the area that we're looking at is 0.086, mean of 0, standard deviation of 1. That will give me that this inside value is negative 1.36581. That's fine. And then we'll do it again for the second area. This time the area is 0.675. So that's 200 minus mean standard deviation 762. Awesome. Now I have two equations. I just need to solve these simultaneously. So we'll go to solve. 180 minus mean on standard deviation equals to that area, negative 1.36581. And the second one, whoops, that's not what I wanted. I just want another fraction. 200 minus m on s equals 0.453762. You don't need that many, but anyway, looking for m and s. So we get the mean is 195 and the standard deviation is 11, which gives us D. All right, next we have this particular function. Which of them could give us GOF? Now, I don't know, for me, the way that I thought about it is just like, what could these equations be? And when I insert f into g, what's that going to look like? So I just made up possible equations. Like that just looks like y equals negative x, because it's going through the origin. And this looks like a quartic, and the quartic goes through 0 as an intercept, and then it's got negatives and positives. So I'm just making up values here. You don't need to. There's no reason to. I don't know, something like that, whatever. It doesn't have to be exactly those numbers, but the idea is that that's a quartic with those particular intercepts. We've got 4 intercepts, and then the other one is a negative x. Now the question is, when I put negative x into that function, if I change all of these x's into negative, what actual transformation is happening? Well, that's a reflection in the y-axis. That's all it really is. So you're just looking for the function that is a reflection in the y-axis. So the turning point over here, we expect that to be on the other side, and that will give us C. Okay, next question, 14. We've got a probability density function, find the value of K. Nice and standard, so we know that a probability density function should have an area of 1. So basically I just need to define this function, make it equal to 1 in terms of the integral, and then we can solve for K from there. What we're going to do is define our function, f1 of x is equal to, and we'll do the hybrid function, this one, and we'll have k times sine x between 0 and pi on 4, and then we have k times cos x, whoops, that's the wrong section, pi on 4, x and pi on 2. Okay, and then we just need to integrate it now, and we're going to solve. So I should have put a solve function between, so the lowest to the highest, pi on 2, f1 of x dx is equal to 1 because it's a PDF, and we're solving for k. And we get k is equal to root 2 plus 2 on 2, and unfortunately that's none of the answers. Could possibly be b because it's a fraction. So what I would think of is trying to, I guess, unrationalize the denominator. So I'm going to multiply both the top and the bottom by its conjugate. Oops, there's no root. root 2 minus 2. So then that'll be a squared minus b squared for the top. So that's just 2 minus 4. That'll be negative 2. And for the bottom, it's 2 times root 2 minus 4. And then we can see that we've got a factor of 2 in all of these. So that's negative 1 on root 2 minus 2. Almost looks the same. If I pull out the negative from the bottom, I get 1 on 2 minus root 2, which is going to be b. Okay, next one, question 15. We've got the graph of that passes through the point 1, 3. What point is it going to now pass through? So we just really need to apply the different transformations that I can see here. So when I do transformations, I just kind of write out x and y with lots of space in between. I'm going to start off with, we've got a dilation of a factor of a half. So remember, it's the opposite when it's in the function from the y-axis. So it's going to affect the x value. Then to see the true translation, you actually need to pull out that dilation factor. So I'm moving every x value, again, the opposite, to the right by 3 on 2. And then we've also got a reflection in the x-axis. So that's going to make all of my y values negative. And then I'm going to add 1 to every y value. Now I'm just going to go ahead and sub in 1 and 3. So that'll be a half times 1 plus 3 on 2. And negative 3 plus 1. So it'll be a half plus 3 on 2, which will be 2. And negative 3 plus 1 will be negative 2. So the answer to that should be B. Question 16, it says consider this particular function given the derivative has a range of 0 to infinity. So the idea is that the gradient is always positive. That's what that's trying to say there. Which one of the following must be true? Now that's in terms of A and B, and A and B will affect the direction that it goes in terms of its gradient. So let's consider all the possibilities. So the first possibility is when they're both positive. This is what my log graph looks like. I can see that's got a positive gradient. It's going upwards. What about if the inside is negative? So we've got a reflection in the y-axis. It looks like that. That is a negative gradient. If I've got a negative on the outside, it's going to look like this. So nope, that's not what it's going to look like. It's going to look, reflection in the x-axis is going to look like this. Don't know why that took a second. That's also a negative gradient. But if I have a negative on both of them, then we've got a reflection in both the x and the y. So it's going to flip like this and like that. You will see that that's also got, no reason for another color, a positive gradient. So then looking at all the possibilities, we can see that A and B need to be either positive or negative as long as they're both the same. That's none of the options listed explicitly, except what we can see is that as long as we multiply them together, it's going to be a positive number. So we know that if we multiply 2 positives, we'll get a positive, but also if we multiply 2 negatives, then we'll also get a positive. So the answer to this is D. All right, question 17, which one of these is going to satisfy those particular integrals? So what is that saying? It's saying that if or the area, not the area, rather the integral value, because the area is when we usually do the signed area plus minus, we're finding the integral value between 1 and 2 needs to be greater than 1 and 3. So what that indicates to me is that between 2 and 3, there needs to be some negative area to take away from the overall area underneath the curve. Okay, so let's just kind of compare what all of them look like. So for A, I've got this large section minus a small section. So there's a positive area. And then if I add on this, that's even more negative area. So what that means is that whatever area I had initially found here, it's going to be smaller because the area between 2 and 3 is negative, it's taken away. So to be honest, it actually looks like it's already A. We can go through the rest of them. So 1 to 2, this is the area. 2 to 3, we've got that part that's negative, but the majority of it is positive. So probably overall, we're going to be adding on area there. So here it will be subtracting. For B, it looks like we'll be adding on area. Same kind of thing here. This is literally just adding on even more area. There's nothing to subtract. Here, the area is originally negative, and then we're actually adding on more area. So that's not going to give us a smaller one. So the only one that's going to be smaller is going to be A. Question 18, consider the following. Which one represents the probability, they represent the probability mass. Which one of them has the same mean? So 2 ways you can do this. First of all, you can do it manually by multiplying each of the numbers by the mean, and then you can compare it. The second way, and it's probably less accurate again, maybe if you have less time or if you're very confident, you can do it this way, is to kind of assume or guess where the mean is going to be. So the mean is going to be in the middle of a symmetrical function, and then if it's not symmetrical, you're going to be leaning towards the side where there's more probability. So for example, for A, the mean is just going to be smack bang in the middle, so it'll be around that 2.5. But for part 2, we can see that we've got a higher probability onwards, so the mean is probably going to be a little bit higher, not quite in the middle, so it'll probably be around that 3 value. For part 3, again, we've got a skew to the left, so it's going to be onwards, so probably going to be somewhere around there. And then part 4, we've got another symmetrical function, so between 1 and 5, the middle is going to be 3. So to me, it looks like both 2 and 4 are going to have the same mean, and that would be D. Last page, super exciting. Question 19, we've got A is on the point of line of that, B is on that particular curve. If A and B are placed such that the line segment AB has the minimum possible length, this length is root 2, what's the value of C? The key thing here is that the minimum possible length between a line and a curve lies on its perpendicular line. So it lies on the normal. So if I were to give this a quick graph, so we've got our normal like this, we've got some sort of x plus c, sorry, not the normal, that's the log, and the minimum distance is going to be at the perpendicular part there. Now, this question is quite involved. There's a few things to this. The first thing, the gradient of our line is just 1, which means the gradient of that normal line is going to be -1 because you flip it and you chuck a negative in it. So the coordinate here is going to lie when the gradient of the curve is -1. So that's the first step here. I'm going to differentiate this function and I'm going to make it equal to -1 so that I can find the x value at which that happens. So if I swap these around, so that'll be -1 equals to x minus 1, x will equal to 2. So that coordinate there is 2, and then to find the y value, I just sub in 2 into here. Log of 2 minus 1, 2 minus 1 is 1, and log of 1 is 0. So that particular value is 2 and 0. Obviously not representative on my graph, I just kind of drew whatever. All right, so we have our first coordinate. Now we need to find our second coordinate. So we can see that the second coordinate happens when this normal line, the red line, intersects with the line x plus c. So I'm going to go ahead and find what this normal line is. I can use my CAS calculator to do that. So we want normal line, and it's of the curve x minus 1, log ex minus 1. And we want to find out what the normal is when x is equal to 2. So that particular coordinate that we've got, I want to find what is the normal line that passes through it, because that'll also pass through the line as well. So this line is y equals -x plus 2. So to find that intersection, I just need to do the intersection between the normal and the curve x plus c. So we can solve, well, you can probably do this in your head, but easier like this. And I want to find my x value. So the x value there, so now we're talking about this coordinate, is 1 minus c on 2. And then to find the y value, so the y value will be when I sub in x is that. So I can do x plus c where x is equal to this value. So that's just going to sub it in automatically for me. That means the y value will be c on 2 plus 1. Okay, so we have now successfully found the two coordinates at which I need to find that line segment. I now basically need to put it into my distance formula. So the distance is x2 minus x1 squared plus y2 minus y1 squared. I'm just going to call this the 2 function, and this one the 1. Oops, wrong way. y1, x1. Okay, so y2 minus y1, so that's, oh sorry, x's, we're starting with x. So 1 minus c on 2 minus 2 squared plus, and then the y, c on 2 plus 1 minus 0 squared. And we just want that to equal to root 2. I don't know why my color just changed. We just want that to equal to root 2. So I'm going to go ahead and just solve that on my CAS. So that'll be 1 minus c on 2 minus 2 squared plus c on 2 plus 1 squared equals root 2. Oops. Classic. Minus c. There we go. So we get C is -4 or 0, and out of all the options, we can only see that there's C is equal to 0. Okay, last one, question 20. We've got let A is greater than 1. We've got these particular functions defined below. We've got a bunch of transformations. It's saying when I apply it to F, which one is going to, or rather not going to give me G. So if you're not feeling confident about transformations and you really want to get this mark correct, I would suggest mapping it. Otherwise, you can go ahead and substitute in, but it is very easy to make an error when you do this. So let's give it our best shot when we do it. So we've got a to the power of x. So first one says we've got a dilation of a half from the y-axis. Now remember, this flips when it's applied to the x value. So that's 2x. And then we've got a translation of 1 unit in the negative direction. And you have to remember, when we apply it directly to the function itself, we put it in brackets. So negative direction of the x-axis, opposite again, a 2x plus 2. So you have to just remember these rules of transformations. So that in fact gives me G. Let's try part 2. So we're starting off with a to the x. Again, we've got a dilation of factor a half. So we apply the 2. And then we've got a dilation of factor a squared from the x-axis. So that means we multiply the outside by that dilation. Now with our index laws, all we have to do is add the powers. So again, we get a 2x plus 2. All right, next one. We've got a dilation of factor a from the x-axis. So far that's going to be x plus 1. Then we've got a factor of dilation 2 from the y-axis. So that means we just replace everywhere that I see x, I'm going to replace by 2x. So that's 2x plus 1. And then we've got a translation of 1 unit in the positive direction. Positive direction means we do the opposite, minus 1. So that'll be a 2x minus 2 plus 1, a 2x minus 1. So that looks like that will be my answer, but let's just try part D just in case. So that's ax times, we've got a dilation of factor a to the 3. So when I put that together, that'll be x plus 3. Then we've got a translation of 1 unit in the positive direction of the x-axis, plus 3. So that'll give me a minus 1 plus 3 is plus 2. Then we've got a dilation of factor a half from the y-axis. So everywhere C and x, I'm going to put a 2x, and you can see that that's equal to G. So the answer for this is C. All right, and there you go. That is all the multiple choice of today's exam. Let me know how you went, if there was something that you did differently. As I said, a lot of this is just kind of how I thought about it. I'm sure there's ways to do things faster or more efficiently, but it'd be great to hear from you anyway. Best of luck.